Welcome to another live engineering design session where I go through, sort of talk through my process designing parts in Onshape. And specifically through this series so far, I've been working on a redesign of a little off screen here that I've got samples of robots that my mechatronics student built as their capstone project. The students, again, of course, always, I can't stress enough, did an awesome job on these little robots. The key thing is a factor I didn't even expect, is that the application that these were designed for, sort of the career fairs, outreach events, taking them around to student groups, they really need to be far more robust, is kind of a good way to put it. So they were a little delicate for that environment. Frankly, those students can be a little rougher on things than I even expected. I thought a quick, we're calling it version 1.5 redesign because electrically it is the same as what the students did. I'm just trying to make it a little more tanky, a little more survivable in that kind of environment. So previously we worked on getting the new primary PCB put into place. This will be a new 3D printed chassis to hold everything together. We made it through getting a battery compartment in, and last week started getting these motor mounts sort of, blocked in and put into place. So that's sort of where we're going to pick right up today, is getting these motors finalized and mounted, and hopefully get to mounting some of these sensors. Now, I see some potential issues here with my original plan. And the original plan was to sort of shove this motor as far back as possible. Now, we got to be careful because you see that orange hole, there's a mounting tab there. I want to catch that with a screw. And everywhere there is a screw, I'm also going to use brass inserts, threaded inserts, to sort of hold it. That was one of the factors I wasn't anticipating. My advice to the students that did the original design was to just thread into the 3D printed plastic into the PLA. I've had good luck with that in the past, but we're dealing with, M2 and M2.5 screws in a lot of these PCBs. And in a lot of the cases, there just wasn't enough thread to hold. I've honestly never done it with threads quite that small. I've had very good luck just threading into the PLA with like a 1/4-20, but there's a lot more thread there to work with than there is with like an M2. So everything will be threaded inserts. We've got the screw bosses here for what will be threaded inserts. I'm just holding off for now on the holes. I want to sort of get all the other stuff cut in that's going to get cut in first, so that I don't, sort of encroach on those holes. But for now, pardon me as I'm still recovering from a cold, for now, we're looking in good shape. And the thing that I noticed, so these motors, they have these little, move this guy out so we can see them. On each side have these little tabs. And my original thought was to set this up in such a way that this is shoved back sort of as far as I can go, which that's too far, right? I got to have this mounting tab in far enough at least to get an insert in. So that's back way too far, but as far back as I can and still achieve that goal. But I also want this sort of leading edge of the motor mount. Uh, we'll call it a block for now. I will smooth this out. And when I design things like this, I tend to wait to do all the prettiness to the end. It just makes things cleaner. Like all of these corners, especially if we look top down, like these corners are going to get radiused. They're going to get filleted. Um, but inevitably, what I have found doing, CAD design is if I fill it too early, inevitably I end up wanting to put a feature somewhere and I need to dimension off of that corner. And if it's rounded, there's no corner there anymore. So that's a problem that I want to avoid. So I'll fill it at the end, make everything pretty at the end. Right now, I'm just adding material to block in the shapes that I know I'm going to need. So, I mean, I guess right now the play would be what I'm thinking is to make the actual cutout for this motor body where I need it to be. I'm trying to think, and then I can adjust the original sketch that created this block, which I believe, if I switch over to the chassis here, this sketch here, I can adjust that, this leading edge to be further back so that the goal will be to just catch this edge of that tab on the back. That way I sort of save myself the hassle of cutting in a precise slot or a precise, hole to sort of fit this tab. And really, it's an anti-rotation tab. All it needs to do is catch that edge, and it'll do its job. Um, and I'm going to leave plastic relatively snug. There will be clearance, but relatively snug on the top and bottom of the motor anyway, to sort of give the screws a little help to eat the torque, so they're not the only thing doing that job. So I suppose the next step would be to just sort of, cut that slot in. I do have the physical motors here. My desk, as I get deeper and deeper into the series, is getting to be a mess. We can't always trust the solid models, and I downloaded this solid model, and there's already some features on it that don't exist on these physical motors. For one, on this end, there's an extra boss in the plastic, a protrusion that doesn't show up on this model at all, but it's moving in the right direction of the camera, guy. There's a boss here where the wires come out, the leads come out, that doesn't show up in the model. And by leaving, this sort of hanging out in the air, I don't have to worry about that either. I don't have to measure it. It's just, hanging out in space. And in this case, that's not always a good thing, but in this case, I think that'll be beneficial. We get to be less precise that way, and less precise is not always a good thing, but in, sort of some cases it can be. So I'm going to go ahead and cut in the motor, this is sort of the motor groove, the motor pocket, I guess we can call it. And it's really just going to be a rectangle. And I'm going to pull some measurements off of this, I think, to get there. And as always, I've just got a scratch pad because honestly, when I take a measurement in one tab, I can't remember, switching to the tab what that measurement was. So I've just got a scratch pad that's got a bunch of nasty scribbles on it just so I can remember for longer than 15 seconds what I was measuring. So from here, and I'm going to go from the seam, not from the face, because I suspect in this model that these faces aren't actually parallel. But if I go from, line to line, they should be. So telling me parallel distance 882, and if I look up in the upper right, that tells me that's Z. I want Z parallel 882. Okay. So 0.882 tall. Now we want some clearance. And honestly, just off the top of my head, can we just call that 0.9? Is that enough? 18 thousandths of clearance, 9 aside. That should be good, and a printer should be able to hold that. Let's do it. Call it 0.9. And then as far as the actual depth, Now, if we look at the actual chassis model, I have a sketch here, highlighted in orange now. This represents where those mounting screws are, at least the points do. So there's, a mounting hole here, a mounting hole here. This point is actually the shaft, and then the mounting hole out on that tab. So sort of this mounting hole. So I've got these two holes, the shaft and this in that sketch. So I've got those as reference. And what I would really like to do, is end up with this edge sort of as close to this surface as I can, because we've already set this thickness of the top. That was like the first feature we modeled way back in episode 1. And we set that thickness, and we sort of need that much material up there. And we know that that's a safe distance to be. Things are happy there. So now the question that I have in my head is, I need to add, what did I say, 9 thousandths, half of 18, and then to this screw hole. So I need the distance from that hole to this edge. Minimum distance. I don't want minimum distance. I want center distance. Center 0.87. 0.87 plus 9 is going to give us 96. All right, so then I can modify my sketch here to move that down. This sketch. Let's edit that sketch. And that hole now needs to be 0.09, 0.096. So it's actually, did that actually move it? I wasn't actually paying attention. Things moved too fast. It looked like it moved. It moved. So I had it at an 1/8. I didn't shave much off, 30 thou, but every 30 thousandths helps, right? So that's there. I'm trying to refresh my memory as to how, so I dimensioned everything based off the shaft, it looks like. I put the shaft 1.5 inches from the back. Some of that I think is going to change. How did I dimension our block? I just gave it a straight 1 inch. And what about the total length? Excuse me. What about this? Something about that doesn't seem right. Let's go back to our assembly. And so the shaft is the driver. Like, I want the shaft as far back as I can go. So shaft to this tab is all the longer I want that motor block. And again, I don't want minimum, I want center. The sketch represents center to that hole. That is Y, right? It looks like it's overlapping. There we go. It is Y. 1.22. 1.22. Now I'm going to shave a couple off of that. Let's shave 5 off. So 1.215 from the shaft. Go back here. Uh-oh, poor connection. Poor connection. Oh no. Hopefully the stream is working out okay. And I actually need to figure out where my little pop-up for my little chat pop-up is missing. Where did you go? See, this is why I'm not, there it is. Just needs to be checked, I think. And it's a blank window. That's great. Blank windows are great. There it is. Now we're populated. Now we're docked. I don't want you docked. Get undocked. This is why I am not a professional YouTuber. This is why I'm a professor, an engineer. You get to watch me adjust my streaming settings on the fly. So there we go. Get that stuff where I can actually see it. There. Now I can actually see chat. Cool. All right. And this is also why I write things down, because I have no idea. 1.215. 1.215. So again, from the shaft to that sort of edge of the boy, I guess that is a poor connection. That took a long time for that to refresh. It wasn't that slow in past sessions. So, all right, so that adjusts that. Now this edge is intentionally a little long. Like from here to here, I could probably be a lot closer. I did it intentionally long. I did it intentionally long because I sort of wanted this edge to line up with the center of that screw boss. Just looking ahead and thinking about aesthetics later, I thought it would look better if there was half a circle sticking out. So I think I'm going to leave that. I think I'm going to leave that, and I'm going to leave that placement alone, 1.5 inches from the back of the robot total. Because if I remember correctly, and this is the see, I don't go back and look at these like you're seeing this on the fly. If I remember correctly, that 1.5 inches came from roughly the center of the battery to put the wheel um, sort of in the middle of the heaviest part of the robot, because the battery is by far the heaviest item on this entire thing. So that shaft, I want to stay where it is. Remembering that now, these dimensions are good. That whole pattern is the whole pattern. It is what it is. We've got that height now. We've got this leading edge now. This height was just an arbitrary 1 inch, which I am going to just plain delete because we're going to set that bottom edge similar to how we set this one. We can go a little further out, and in fact, we probably should, because up here we have all of this wall. By the time we cut into this, we got all that wall. So I want the 0.096. That's going to be, the 0.096 represents where the cut is going to be. So I'm going to extrude this, there'll be material there, and then I'm going to cut it right back out. But I want the 0.096, and then I need a wall after that. Is 1/8 of an inch good enough? I mean, we could try it. Handy dandy calculator, because I'm not adding that in my head. Let's add 1/8 of an inch and 0.096. 221. I mean, let's try it. Why not? We can always undo. So from there to there, calculator says 221. So actually bigger than what I had, 0.221. Ooh, do we need it that big? Do we really? That seems big. That seems awful thick. Seems like it is going to be down with the thickness. Do we like that? Well, I'll see it. We'll put the motor in. We'll cut it, and we can always change it. We'll cut it in and see what it looks like. Now we need the cut. So I am going to easiest thing I think. Again, I don't know. We're doing this on the fly. Easiest thing I think is going to be. Let's slide this out so we can see it. I think is going to be to cut this full depth out, and then add a shelf back in to support this tab. I think that'll be the cleanest way to do this. I mean, it's possible I'm wrong. That has happened many times in the past. But I think that's probably the way to go. So let's do that. So I said full depth less, bring it back in. So one of the issues we have run into is binding of the wheels on sort of the current designed robot. Wheels sort of bind, and there's a couple of different spots they bind. One I'm taking care of just by nature of this thing being out in the air, right? The original design, the wheels were sort of, get the camera right. The wheels are sort of tucked, and show the side that doesn't have all the wires. Wheels are sort of tucked inside. And they effectively have a fender, and the fender, as these things get a little beat up, the fender starts to bind a little bit. So we're taking care of that bind. The other bind we were seeing didn't actually happen on this. It happened on I had a student do a pass at this revision, sort of a prototype, if you will. And we were getting binding on the inside as well because the motors were too close to the actual chassis. So all of that to say, as I'm looking at this motor and this wheel seated on it, I don't believe I trust I don't believe I trust the shelf on this shaft to give us enough clearance. That's really what I'm getting at here. That's my thought. And I'm looking at this motor in deep thought, and I just don't trust it. I don't trust that shelf. So we're going to build in a little extra gap, and that little extra gap is going to come from this face of the motor to the face of the chassis. I mean, realistically, it's the only place it can come from, right? Unless I put a spacer on the shaft. That's about the only place it can come from. So, I mean, we don't need a lot. 5 thou. Do I have a distance mate? Parallel. I already used a parallel. That's a width. I don't want a width. A distance mate is where I would jump in SolidWorks with this particular problem. A problem I have had many times in the past. I just have to figure out how to get there in Onshape. And then that's part. Also, I mean, frankly, let's be real. That's part of the purpose of this series is I'm also not very good in Onshape. I've been using SolidWorks for like 20 years. Very good there. And I wanted to put Onshape through its paces. So that's why we're here and not in SolidWorks. I mean, does a parallel have a distance limits? Hey, look at you. Here. That's the X. So what if I set the min and max the same at 5,000? 0.005. 0.005. And it looks like it took that 0.005 helps. It didn't move anything yet. Let's accept it. Did it move? That certainly doesn't look like 5 thousandths. That looks like flush. Okay. Is that maybe not what I wanted? Let's edit it. Is that maybe not? Is there another option under parallel? Oh, that just changes the type of mate. Flip, reorient, animate. I don't necessarily want to do any of that. I definitely don't want it. I definitely don't want it flush either. But by setting up min and the max the same, one would assume that it would sort of lock it in to be 5 thousandths offset, no? Seems a little odd to me. I mean, what if I 0? I mean, something moved, but one thing I've noticed in Onshape is stuff kind of moves way more than I would expect it to anyway. Like, well, first of all, I am looking at X, right? Like, yes, like that is the X direction. Oh, no, it's not. It's not. It added its own little coordinate system just for this mate. So I'm actually going to delete that guy now that I see that. Delete. Because I deleted it because I don't know how to get it back to no limit. Like originally that thing said no limit. I don't know how to get that back other than setting it to 0. So I'm just going to do it again. All right, mate, set limits. That is Z here. What if I do Z and set them both the same? 0.005 and 0.005. Sounds like it should lock it in. Is 5 enough? Just looking at things, I don't like 5. Just looking at things and looking how tight this physical motor is, I don't like 5. So we're going to go 10. And we're going to call it 10. And we're going to live with it. And frankly, we're dealing with plastic, and I can probably squeeze a little more out of it if I just crank down on the screws. You didn't hear me say that. Let's accept that. I like that. So we're sort of locked down at the depth now that I want that pocket. So now that we're locked and I can't drag it out, now I can go from this face to this face to get the true depth that I need to cut out. Right? Right, I think. And that is 722. 0.722. And if you're wondering where I'm looking, it's down here. Oh, hey, look at that. My face is cutting it off. Let's adjust the stream on the fly and get out of there. Hey, look at me. Now that honestly, now that bothers me because now I'm not in the corner. Anyway, measurements may be slightly more important for what we're doing here than my face being perfectly in the corner. So from there to there and down here in the bottom right is where I'm getting these measurements, and when I expand it, it gives me the X, Y, Z and different options for what I'm actually looking at. But from here to here is parallel, and if I close that, just this distance is good enough. And actually, it's not. Well, the motor model's probably metric, but 722 is close enough. It'll stick out a little further. I mean, I really don't care. So 722 is close enough. Yes, 722 is close enough. And let's go back to the chassis. So 722 for the depth. I now need to figure out, where that cut needs to happen. So I need to cut out. I wrote that down somewhere. See, this is how big a mess. So I'm adding 18 thousandths to whatever the height of the motor was, and I don't think I actually wrote down the total width of the motor. Motor. 882. I did write that down. That's where we got the 0.9 for overall width and the 18 thousandths. So my bad. But probably should do it from here to here. Yeah. Hold. Since I've got that sketch defining the holes. All right. I don't want an angle. I want a distance. Center distance. 0.087. 0.087. Okay, that's where the 0.96 came from. That's where I need to cut. 0.96 off of those holes will define the height of that rectangle. Then all we need is, I mean, effectively where the back of it is. And I mean, we kind of got that. Yeah, so we've got this and we've got this. And if I get a center distance off of that, is that Y? That is Y. 118. And if I add 10 thousandths just to make it clear, I mean, that's not doing it shouldn't be doing any torque stoppage for us. We just want clearance. So 10 thousandths, or I could make it just a nice round number and do it 125. I mean, 7 thou, 10 thou. What's 3 thousandths between friends, right? 125. I like that number. So 125 off of this hole and 96 off of each of these holes should give us every dimension we need to define that thing, assuming I can quit talking long enough to remember the plan. So I need a new sketch on the part. I need a rectangle. Now it's going to be flush with this edge because we're going to cut all the way out on that sort of leading edge. And we're going to go, I could, now if my measurements are right, and I did all the dimensioning correct, I could just make it this top of my cut even with this top of this sketch. I could do that. I probably should do that because I should rely on the dimensions I already calculated. However, I almost never trust the dimensions I already calculated. Like, seriously, you should see how many times I redo the simplest calculations. 0.096. And that should line up anyway. Like, it's almost indistinguishable. And so far, my only major gripe about Onshape is how much these sketches move when you add a dimension. Like, why? Why did that whole thing grow? I don't know. Can't tell you. It is mildly annoying though. And then 096 off of the bottom hole. Now, the other question is going to be if this is far enough out to actually get an insert in. Like, we need enough room between this dot, which represents the center of the hole, and the wall to actually put a hole in here for a threaded insert. That is a factor I have not considered yet. It is not a factor I have forgotten. I just haven't considered it yet. So from here to here, we said 125. This back wall is a little thicker. Like I said, that was intentional last week, just so that it intersected the center of this screw boss. I think that just from an aesthetic standpoint, it's going to look better with half a circle rather than I mean, if I made it thinner, it would be more than half a circle. This would sort of dive back in, right? And I'm just looking ahead, and aesthetically, I'm not sure that's going to be awesome. So this is why I need better notes on my scratch pad. 722 deep, I think, is what I had. So we're going to extrude. We are going to remove material, and 0.722 sounds like what I had. All right, accept that. We have a cut. We have a cut. Now, if I come back into assembly 1, I'm actually going to delete the mate we made, the parallel mate, because that literally only existed so I could get a decent measurement. I do that all the time in these kinds of designs. And all of these parallel mates, ooh, that's actually for that. Okay, I'm trying to find the other. Okay, there's a parallel mate I'm going to delete everything that has to do with this one motor for now. That was a parallel mate to hold it in that orientation. What's this one? Is that the other motor? Yep, that was the other motor. So the other motor I'm going to ignore for now. But this motor should now be like completely free. I'm not going to rotate it or anything, but it should be like completely free. So now I can just plain old mate it to the back of the cut. Good. And I may do another temporary mate because I may, let's get out of here for now just because red bothers me. I should, can I show that? Why is that sketch not showing on my, well, first of all, I didn't realize that came in as part 1 for reasons I don't understand. I'm going to see, can I just rename that? And chassis so I don't have to guess what part 1 means. Do we have properties? Properties. Hey, look at you. Chassis. I don't want to have to guess at what part 1 means. Apply. Close. Okay. The sidetrack. This is my natural back and forth, right? Why in the assembly is my sketch not visible? I suppose there is one thing I could do. I mean, to not need the sketch, and I could just continue and put the holes in for the threaded inserts. So the threaded inserts are going to come from McMaster. And actually, it's still in my search history. We're going to use the heat set inserts, not the tapered ones, the straight ones. And I do believe we decided, first of all, we need metric. I think the holes on the motor are an M3, but they're a little snug for an M3 based on my caliper measurements in the solid model. So I'm going to go with the M2.5. I'm going to go with the longest version they have, because if I then decide to go shorter, I mean, the hole's already there for a longer one. So drill bit size number 20. So I need a number 20 hole. Minimum material thickness 6.5 millimeters. I never converted a metric. 6.5. 25.4. Just over a quarter inch. So if we go 0.3 deep, we're fine. We're fine by a lot if we go 0.3 deep. So I'm going to go back to my chassis. I'm going to drop just the 2 holes in that correspond with these points. Because, like I said, I'm going to build a shelf. I'm going to extrude a shelf back up to meet the screw tab for this outer hole. And I don't want to put the hole in yet because it'll have to be on that shelf, not on this back face. So first of all, I need to select that back face and not the sketch. That's another, I think, mild annoyance of Onshape, is that it because this is a closed sketch, it selects it rather than the surfaces behind it. Mild annoyance. So far, I have not run into anything in this software that is more than like, yeah, that's slightly annoying, right? And I mean, it's been fully capable of everything I've asked it to do. So I'm going to drop a couple of points in that are going to end up being holes. I am going to just make them coincident with these sketch points on the one that's still showing. That's why I'm not just hiding that sketch. It's there for a reason. I mean, I could solve my minor annoyance just by hiding it, but I want it there for now because it's referencing everything. Like I'm building everything off of that sketch. So except we got the 2 points, grab that sketch and hole, and that's going to be way too big, but we want a number 20 drill bit. That's what they said, number 20. Okay, so we fit. That's important. Are we not deep enough? We are. Ooh, yeah, we're not deep enough. We are not deep enough. We're going to have to screw. We don't have enough back wall here to make that work. And I want to make sure that's not, as long as the top one's not punching into the battery compartment, we're okay. It's not punching into any of those recesses we made. Is it? It's not. And I can verify that. Can I make this transparent? Well, first of all, let's finish the thought. So machined, I would leave the end condition of the hole. Actually, I didn't set the depth. Yeah, that helps. We may not be too deep. So what did I say? 0.3. Hey, look at that. We have plenty of material. We're not punched through anymore. Yay. Pay attention to your own work. All right, now what I was going to say is the end condition here, the 118 degree drill bit. Normally I would leave that alone, especially if this were machined. But this is a 3D printed part, and it's going to print exactly the way this model is. So in this case, I'm going to change this to be a flat bottomed hole. Because we're not drilling it, right? And there's no reason to print a cone. It's a flat hole. So I like that. Now, I still want to make this transparent because I want to see how deep we are. Make transparent. Oh, that's plenty. We got plenty on the bottom. I'm not even going to measure it. I'm not even going to measure it. I mean, look at that. Lots of material. Okay. So get rid of that. Go back to, full mode. Now, if I hop back into the assembly, I should be able to mate the motor to those holes. So I'm going to slide our motor off. So the other option would be to do a width mate between the slot, because that should get us in the same spot. I would rather mate it with the holes if possible. I say if possible because converting from metric to standard, if I just screwed something up, because I do believe I converted from metric to standard and back to metric to get an idea of what the actual sizes were, which means things may not line up lining it with the holes. Or, because any CAD, this isn't an Onshape thing, any CAD wants this to be perfect. Like if these holes are not perfectly distanced, it will not allow them to mate. In which case we can cheat it and use a width mate, because we know no CAD model is ever perfect, or I should say CAD models are perfect. The part coming off the printer is most definitely not going to be perfect. And we can cheat, half a thousandths here, half a thousandths there. And get rid of that because I don't like red, and it actually like that. So, I mean, all that back and forth conversion last week must have actually worked. We've got clearance here. Not a lot of it. I don't know if I like that for a 3D printed part, especially on printers where I don't know they're actually capable. I never actually checked that tab. We're clear on that tab. If I get the angle just right, we're clear just enough. Yeah, I can live with it. We got enough material to, we got enough wall clearance from the wall to get our inserts in. We got enough backing material. I think I'm cool with it. Now, we need a shelf to come back up to meet this tab. So I need the distance from that back face up here. And that parallel distance is 327. In this case, well, I don't need the detail, but I do want more decimals. Let's see, 327 in this case because it rounded up. 32, make sure that's visible on my stream. Yeah, it's visible. I don't know how big it is. but it's visible anyway. So 326772 rounded up to 327. I do not want to round up in this case. It'll be too tall. In fact, if anything, I want that to be a little short. So I'm going to go 325 deep. Write that down on the pad where I already can't find anything. 325 deep, or tall, I should say. I'm going to extrude off of this back face 325 back up. And then as far as how the size of that, so from here to here, 243. And again, I don't want to be long. Okay, they rounded down, and I want to actually shave. I mean, at least 5,000. Let's go 235 there to give a little wiggle. Again, the printers in the lab at Baker, I do not have I just haven't run enough tests on them to know exactly what they can hold. Here, my Ender, I definitely have, and it'll hold 5,000s all day. Like, I mean, people talk crap about the Ender, and it's, especially mine. I mean, mine, I think mine's a straight up Ender 3. No V2, no Pro, just Ender 3, right? And they talk crap. And I have definitely put a lot of love into it, trying to dial it in. And now it is an awesome printer. I cannot say the same for when I actually got it, but it is an awesome printer. It definitely took a lot of work to get it to that point. Yeah. So now the question is, the reason I got quiet all of a sudden is I am already, my mind, this is how my mind jumps ahead and gets lost. I'm already jumping ahead to aesthetics. Like, I'm going to build a shelf back up to touch that tab, or be just short of it. I wrote that depth down right. Yes, I did. And then I'm wondering how that's going to look, because we're just going to have an open pocket there. Do I like it? I mean, aesthetically, I'm not nuts about it. I think I almost think I'd rather come all the way back up on either side of the tab and just let the tab itself be buried down in there. But I mean, for now, I'll live with it just being a shelf, I think, and maybe deal with the other issue later if I really don't like the look. I mean, because at this point in a design, there is as much art going on as there is science. Like, a lot of it's aesthetic. Do I like the way that is looking? So we're gonna build that shelf. We know that it was 235 here, and then the depth 0.235. You can't grow if I constrain you on every other side, right? So there, I'm going to grab that sketch and extrude it to 325. That'll be our little shelf. And now, while I'm in here, I don't even have to go back on that. I'm going to have to, yes. I'm going to have to hide that sketch, I was going to say, but I can sneak in, I think, and grab that surface to sketch on. So sketch, I need 1 point for the whole. 1 point is all I need. 1 point and 1 point only. So there, it's going to be coincident with the sketch point, and that, I need to accept it first. Genius. Whole, we're already at number 20. We're already 0.3 deep, and we're going to make it flat and accept that. And if I then, that wall right there, I can tell you is looking ridiculously thin. And depending on how much now usually when I use, I'm going to be honest, I've used these a ton in plastic. 3D printed plastic as well. I will be honest, I have absolutely never heated the plastic. I've never followed the directions. They're supposed to be heat set. But honestly, in PLA, I have found just pressing them in. Now, I'm gentle. I press. I don't like pound them in, but pressing them in gives, especially at this size, like I've got a couple, I think, of 1 millimeter and even 0.5 millimeter inserts behind me. for some projects from a prior life as a designer. But I've had good luck just pressing them in without the heat. Now, knowing what I know about mechanical engineering, pressing something in with a wall like that is going to cause a bulge. That bulge is a problem because we just only designed so much clearance in. However, if I actually use the heat, I don't think we're going to get a bulge. The idea of the heat is that it is not, pushing material out of our way. It's liquefying it. So I think that should be okay. Maybe, possibly. Sure. Head back to the assembly just to make sure that hole lines up. It does. I'm happy. Yeah. So for now, I'm going to check the physical motor. I don't think there's anything hiding in, like, those two grooves are grooves. And they are, right? They're holes in the plastic housing that wrap around the motor itself. So it doesn't show up real good because it's one solid model. This outer surface is plastic, the blue plastic here. And then in here is the actual motor. So this is a sleeve around the motor. So there's nothing actually in here but motor casing. Nothing to worry about, nothing that we have to clear. There's nothing on top that we have to clear. The leads are sort of down, from the surface, so we don't have to clear that. We can come straight out the ends. Yeah, I think I like that. It honestly, at least for now, I like that. Again, I will come back and fill it later. Like I will, fillet this to sort of match that contour a little bit. We still want clearance, but I'll match it a little bit. And if I look, we're clear top, we're clear bottom. I like it. I like it. For now, we're going to call that motor mount done. And then we got to take care of the other motor. So I'm going to do the same thing and delete all of the mates. Just going to straight up delete all the mates that have anything to do with that motor. And that should start right here. That's that one. That's that one. And these are mates for that other board. So this motor should now be completely free. Now back to the chassis model. And the reason, now, most of the time, I don't think I mentioned this, most of the time I would have created this, because we created this original, like this PCB platform, I guess we could call it, was the genesis of this. This was the first thing I modeled. Normally, I would have put this rectangle with this like corner at the origin. I did not do that, and I did not do that anticipating that there were going to be things I would want to mirror. Like, I do not have to remodel this motor pocket. I can mirror it about the right plane here, and I will get an identical pocket over here without having to redo all of the sketches and building up that I just did. First, before I do that, I want to see what my capabilities here are for grouping. Can I put these in a folder? Add selection to folders. So this is, looking at this thing, this is the front, that's the right motor. And I generally, just for me being, sort of anal retentive, I generally don't put spaces in the names of things. And that is just an old habit. I ran Linux on my desktop for a very long time, and during the years I was doing that, Linux did not like spaces. It didn't play nice with spaces in file names, and that was just a habit I got into. So very rarely will you find me name something on a computer with a space. Underscores if I have to, but so I should be able to take that whole folder. Can I do that? And mirror it? No. Not a part mirror, a feature mirror. I ran into this once before testing things out. So feature mirror plane is going to be, I can set that the right plane, and it doesn't look like it'll let me just grab that folder, but I can expand now and grab everything in that folder. And I think I don't know for sure, but I think I want the sketches too. I think now it's red, and red bothers me, like as if it's going to fail, Cannot create all instances as entered. Try reapply features. Ah! Boom. What? Reapply features. I mean, I'm hoping that's just a regen thing. It's not. What the hell happened? I mean, the cool part about a mirror is I can just kind of, delete it. Why didn't you like me? Well, let's not grab. Well, I kind of gotta grab that sketch, don't I? Like, I kind of gotta. What if I just grab the features, the actual features, none of the sketches? Let's mirror you. Let's see what happens. And I already named the entities. I mean, come on, man, you're killing me. We want to do a feature mirror. I want the extrusion. And let's grab the right plane. I want to see, this is a trick I would use in SolidWorks too. So if I grab, what are you doing? Why? Oh, I see what you did. What if I accept that there? Yeah, it doesn't like it there either. Edit. Didn't I have reapply? Oh no, I didn't reapply. There we go. Let's say what it did was cut out where this screw boss is. Did you catch that? If I don't reapply, that's where that hole, and that's what my U was coming from. If I reapply, okay, and if I features, if I start adding, what if I do this? All right, there's my cut, and the holes, and they don't go all the way through anymore, and that extrusion, there's the shelf and that hole. All right, so maybe it just didn't like the sketches being thrown in there. I don't need the sketches. I mean, I mirrored the features. The sketches were just there for construction. So I guess that's it, right? And I'm going to go ahead and rename that left motor. So I got a right motor with all the features in the sketches. I got a left motor, and I can finally get this friggin' sketch out of my sight. Hide that. I don't want to delete it. I mean, one, because a lot of things are constrained to it, so don't delete that sketch, whatever you do. And I can hide that. That's the PCB. So I can hide that for now. I should have all the sketches out of my way now. So this is where we stand. We've got our motor mounts. Let's go ahead and get this motor locked in, and then we can, move on, get going. And actually next, I had talked, I think in the video description that's up right now, talked about going to sensors, but I also want to get the wheels in here. And I have a couple of tweaks to the wheels that need to be made too. So I am going to, let's see, we need to mate planer. Get this motor locked down. Focus. One thing at a time. Don't get too far ahead. Focus. So we lock that down. This, we're going to do a revolute on this bottom edge of that hole. Now that is the, whoops. Nope. Get rid of that face. The motor's upside down right now. That's actually the bottom hole. Accept that, and another revolute. This is the top hole. Accept that. It should flip it. It did. We like that. And honestly, those two should be enough to lock it down. Yeah, we don't have, make this bigger just so I can prove it. Yeah, we don't, it doesn't have any degrees of freedom. So those two holes and the planar mate to the back were enough to lock it down. And actually, revolute, I may not need the planar. And in fact, I'm going to test that. Revolute should, because I grabbed the whole edges, should also lock it in place on the plane. So I'm going to delete that and expand this again just to prove it. Yeah, I don't have any degrees of freedom. And what if I get rid of this one? I should have the same thing. If there were degrees of freedom, there would be a little axis symbol here, and there's not. So the two revolutes alone, that is cool. So I actually really like that feature of how these mates operate versus SolidWorks, because in SolidWorks, I would absolutely need a concentric mate along with the they don't call it a planar mate, and I'm thinking what does SolidWorks call it? I'm blanking right now. Just a mate. I mean, or a coincidence. I think it's probably coincident, but yeah. So now, one concern I've got, and one of the reasons I want to put the wheels in now, first of all, the wheels need some modification anyway, just some minor tweaks. Again, the whole point of this is basically to make it more robust for the career fair scene, right? Um, the wheels need some minor tweaks, so we got to touch them anyway. One of the concerns I have is where we put this if the wheel is tall enough to hit this PCB, and not only hit it, but remember, I'm not going to leave this edge of the PCB unsupported. I am going to come up with plastic, 3D print material up here to support that PCB and also give us a place to put at least catch these two mounting holes. I can't catch the other two. The main PCB is going to be in the way if we look straight down, but I can catch the outer two and give it a lot more support than just cantilever, which honestly the current design, the current prototype was just cantilevered out there. So the current 1.5 prototype, not the student version. The student version's awesome. They mounted the whole thing down. But the prototype 1.5 is just cantilevered out there, which kind of works. But again, robustness is the whole point of this. I don't want to leave a PCB just kind of hanging in space. I just don't want to do it. So I'm not going to do it. So we need to get the wheels in. And I need to see... Did I download the wheels? I don't remember. Because the students designed the wheels. This is all stuff. See, how far can I go before we get embarrassing in my downloads? I don't see any solid models. So, I'm going to pop into my Google Drive, which I've got open in this other window. And I am going to search for Baker wheel. It's amazing to me how Google search in a drive works so well sometimes and not at all other times. Like, I can search and not have any idea what the file is called, and it'll come up with it one time. I know it's at least got wheel in it. Wheel plate. That's a different project, a different capstone. All right, so let's search on Stinger. Those are my PCB files. Revision, that's the PCB files. Stingers. All right, it's going to be in whatever folder that's in. So move, and don't move, but jump to that folder. Why didn't you work? That always works. Why didn't you work? I'm live. It can't be not working while I'm live. That just doesn't work. Capstone. Find the right capstone. There we go. Models. Baker wheel. Ultrasonics Baker wheel. Got to be that one. Let's download that. Insert. Oh, sorry, not insert. We want to import first. Baker wheel. Models with y-axis up. That doesn't matter. That might. I don't remember. I'm going to set it myself anyway. It is a single. It should be fine. Well, it should just be fine because it's just a single part. I mean, the other stuff is mostly I worried about it when I'm bringing in assemblies. We got the wheel. All right, nice Baker College logo they cut in there. It prints out really cool. Because we got a multicolor printer, so this is actually red. I mean, it's nice. They did a great job. There are, however, a few issues, and I'm going to bring it in, and I think we'll be able to see what they are. So I'm going to bring it in here. Let us insert, now that I have it, the Baker wheel, and accept that. I am going to mate it revolute with this inner and this here. And I'm doing this side first because, all right, I need to flip that. I'm doing this side first because yeah. Yeah, that's, remember I was worried about hitting that PCB. I definitely hit that PCB. Well, that's a problem. That's a thing we call self-clearance, right? I mean, eventually it'll grind the PCB away so that it works. But this wasn't a problem on my student designed prototype because his was a lot taller. Like I shrunk this down as short as we could get it. His motors were mounted down further. I mean that's an option. So option one is going to be to get taller. I don't know that I like option one right now. I kind of like, and I'm going to put this back together. I mean, I broke it. I broke it trying to see some things, and so I'm going to pop this motor back in for starters. Actually, I'm going to unceremoniously sort of break this lead off since I don't think I've got a wire cutter. Unceremoniously break that copper wire and then pop this motor back in into the spot. Is that the right direction? Or is it this way? Was it this way? It was this way. Was it that way? I gotta think about this now. Which way it was mounted in there that way. I think. Does that line up with his? Yes, that's the direction that lines up with his screw mounting holes. So it was in there that way. Well, part of it was the motor in this version sticks out way further from the body. That's one. I mean, if we went out further, like the board, that power board on this is even with the edge. And since the motor sticks out way further, it just plain clears it. You know, I got to be honest, of all the options, I kind of like that one the most. I kind of like our plan leaving the wheels. I kind of like the plan leaving the wheels centered. Or not, well, they're not centered, but leaving the wheels so that they are centered over the biggest mass. Right? They're right under that, where the battery center of gravity should be. I'm not saying, I mean, I measured the battery pocket, right? I mean, but we're close. We're close to like where the heaviest part of this robot is. So I think, honestly, I mean, if I had to make a command decision, I think I like just moving it out to clear that board. Looking at the side, the only thing on the side we need access to is this. That's the actual battery connection. So the battery cable will reach out and plug in here. We're clear of that. I just got to get clear of the actual PCB. And I think I like that. We just leave the motor stick out that far. I kind of like, I mean, I kind of like it tucked into. But these are decisions that we have to make. And it's a trade-off. I mean, the only other option is to move the wheel forward. I don't like that. I don't like that. So we're going to move it out. I mean, I don't see another option. All right, so close that. And then the question is going to be how far out. So from here to here, whoops, grab the right surface. So from the board edge, and we aligned this pretty close. I mean, I did not align it, if I remember. Whoops. I aligned the PCB here with the holes in the PCB here. So despite the fact that these pins, if you look, are not centered, the board is as aligned as it can be. Now, the caveat there is, remember, there is no such, the CAD is perfect. There's no such thing as a physically perfect part. And I mean, if I'm off when I solder these, they're not going to be perfectly centered. So I need to clear the board and then some just to make sure I account for any. I don't want to introduce more interference than, like I said, we have binding now, right? I don't want to introduce more. So there is that. There is that. So how far out do we have to move that motor? Let's focus on the problem at hand. From there to the PCB edge. 247. I'm not sure I like, with all of the stacked up stuff we could have to deal with. I don't want to hold it, and we're not dealing with 3D printing here, right? If I was dealing with 3D printed part to 3D printed part, I've been talking about like the 10 to 5 to 10 thousandths of clearance everywhere. I don't have that here. Like, there's a lot more stack up than that can happen and cause rubbing and interference, and I don't want to run into that issue. So 247 is where we're at. I'm thinking 375. Good. I was going to say rounded number. It's not really a round number. It's a round number if you think in imperial units. But I'm thinking 375. We move it out, I think. So let's see what that does. Chassis, we want the right motor, and we want that pocket. I should, now, because I came back with this shelf off of this surface, because these holes are based on this surface, if I move that surface out, 375, everything should go with it. So really, I just need to find, I'm on the wrong side. I need to find which one was my cut, which was, I think, that one. So this features my cut, and I just need to change the depth and take 375 off the depth. Edit. So 722 minus 0.375. 347. 0.347. Ew. Gross. Let's look. Update. Thank you. Ew. I mean, like, ew. You ever see Avengers and, they ask Thanos, what did it cost? And he says everything. Like, ew. Like, ew. Ew. And I mean, even our tab isn't, the cut in for the tab is ew. But I didn't leave myself with a whole lot of choice there, did I? I didn't leave myself with a whole lot of choice. Now, I'm just curious because the student prototype missed it by a mile. And I can prove that because before I disassembled it and, frankly broke it, it was driving around. I just want to check some dimensions on this one to see. So again, the connector's got a lot of tolerance that it could have, that pin header. A lot of tolerance potential there, but it's basically 950 to the edge of plastic. So from the inside edge of this, I got 950, and I'm just looking for ballparks because I know things aren't precise. So, I'm already 300 thousandths short. because I went so narrow with the board. I'm 300 thousandths further in than he was. So that'll affect that. Um, and then if I look, I mean, his motor sticks out as well on top of that. So like he's well clear, and his motor mount is also, um, only about halfway, which is exactly what I've got. So I don't like it. I mean, I may, before we are done, I may add some material out here just to like aesthetically cover that motor. Um, that may be a compromise we make later. I definitely now, I mean, 125 thou is what I should be here, right? If I did my math right, I should be an eighth of an inch. Close enough. 3 thou, again, there's a lot of slop that can happen in this connector. I hate it. I absolutely hate it, but I got to be honest, occasionally you have to do design things that you hate. I hate it just from an aesthetic standpoint. On the bright side, these original bosses or motor boxes or motor blocks, whatever we want to call them, don't have to be anywhere near this deep. They don't probably have to touch the battery anymore. So I'm going to go back and edit that. And maybe, I mean, maybe as I look at this more and envision it sort of filleted toward the end, maybe I can sell it in my own head as some sort of cool wheel well design. I'm not sold on that idea right now, but it's the best I got. So I'm going to try it. I'm going to do it for now. We can always change it later. So right motor, that's this extrusion. I guess I can cut just the 375 off it, right? Like we did. So it is what now? 125 minus the 375 we just took off. That's 3/4 of an inch. So I'm going to edit that. Edit 0.75. Whoops, 75. Ew. Gross. I mean, ew. Gross. I mean, it's minimalistic, right? As little plastic as we possibly could have, I guess, question mark. I'm gonna leave it there. I'm gonna leave it there and I'm gonna leave it there and suck it up and it's gonna be what it's gonna be. So now the wheel has degrees of freedom because I never locked anything down. It's allowed to rotate. Honestly, I would normally in like a SolidWorks model lock that down. It's a wheel in this case. I mean, rotating is kind of what it does. I already know from the physical parts I've got that there's if I go back to the wheel, there are flats to sort of key it to the motor anyway. So if it rotates in the model in the assembly here, that doesn't matter. So I'm just going to leave it with degrees of freedom. It's free to rotate. Alignment is going to lock it down on the physical parts anyway. I'm going to leave it. So the problem is though here. Like if we look here, it looks really, really bad on this model. Honestly, it is not much prettier in real life. There's a lot of interference and a lot of rubbing and binding that happen in this area because this thing actually does exist. That's part of the blue plastic on this motor, as well as this tab out here. It does interfere with the wheel. So overall, the wheel needs to be a touch narrower, enough to clear this tab. It also needs to be inset in order to clear this little plastic pin that's there for reasons I can't understand. So, like, why would you put protrusions on the side that is designed to accept a wheel? I don't know. I mean, it's not like it's a dual shaft. But anyway, that's me ranting. Let's not rant. This is meant to be educational. So anyway, that's what we got. I can't go any higher. I would like to go higher. I mean, that is really, compared to the other designs, way high off the ground. I would love to get higher than that, but we'll see what we can do later. Um, ooh, I just also had a wicked idea later to how we can fill this gap. Does that say 300,000's even? I like that number too. So, spoiler, I have an idea, and hopefully I remember it when the time comes. The original robot design, I'm going to kick back to the full screen just to make this big enough for y'all to see. The original design rides on the 2 wheels and just 2 carriage bolts, which works great. Awesome. Absolutely awesome. In an effort to cut down the number of parts, this was not a robust thing. This was just to maybe simplify assembly, cut down parts. I like what the student did with his prototype, and he 3D printed in basically flat bottom. These are flat bottom pyramids, but really any. But the feet, what would be carriage bolts, he put right in the 3D printed part. I like that. Where my mind is jumping, and I'm going to go ahead and draw a sketch. Where my mind is jumping is to fill this gap. Now that we have an ugly gap that I hate. If you can imagine, I'm going to actually, I need to go to the part, don't I? I will sketch what I'm thinking, because eventually we're going to need a feature similar to those feet, right? It needs something to ride on. So what I'm envisioning, and this is a spoiler because I'm not going to get there. I'm not going to do this. That's going to be like, I envision anyway, that being the last feature I put in, because the other stuff's going to get in the way if I do it first. But if I just draw a sketch just to give y'all where my head is at. So from the back, imagine it filling that gap, 300,000's wide. And if we did something kind of cool, like a big old curve, maybe not that far back even, but a big old curve, something like that, right? And then came up, sort of in the other direction. And in filling that gap, that would work for the kind of foot or whatever we're calling it. It would do the job of those feet that are molded in, of the pyramid things that are molded in, or of the carriage bolts. But we could make that work. We can make that work with kind of a cool design element in there. I'm suddenly not so hateful. Suddenly not so hateful of the gap. Now the trick will be, and God, I don't know at the pace we're currently going, in another 6 weeks when I get to these feet, remembering that I was not so hateful of that gap. That'll be the trick. So I'm going to go ahead and get out of this sketch. I'm not going to save it. That was just for demo. We're back in the assembly. We're clear of the board. Like I said, a couple of options. I mean, I kind of want to bring the plastic out over the motor. I'll probably do that too later. I mean, we got half the motor. We got it captured. I think we're okay. I do want to check. I want to make sure I calculated the hole depth correctly originally and make sure we got enough material. So first, I'm going to do that. Let's go transparent. Where are you? Make transparent. Okay, we got enough hole bottom. That's all I wanted to see for those inserts. So we're good. We're good. I have an idea to fill the gap way later. Because I don't like that. That's yeah. Especially, I mean, I would if it was just a gap, I'd live with it. What I don't like about it is the fact that these screw bosses are kind of just hanging out in there. That's really what I kind of hate. But like I said, there's now a plan to sort of fill that in, and we can take care of the aesthetics and add a feature that we're going to need at the same time. So we'll plan on doing it that way and leave it like this for now. We'll cover up these motors with some material later. I don't think we need to make this any deeper. Like, I don't think I need to come out with the motor pocket and support the whole thing. We've got the screws. We do have at least half of that. This is actually, the square is actually the gearbox end. We do have most of that captured with plastic, halfway anyway. We've got 3 screws holding the thing in. I think we're okay. So, but we need to modify this wheel ever so slightly, and there's a couple of things I need to do. One, it needs to get thinner, thin enough to clear this. So where are we now? We should be interfering, and if I measure, we're interfering by 13 thousandths. So I'm going to shave 25 thousandths off of this wheel. Just straight up shave it. I am then going to sort of hollow it out, which will make it lighter, which is a key for any battery powered anything, right? Weight is at a premium. Any mobile robot like this that's powered on a battery, every ounce is premium. So it'll make it lighter. I'm going to sort of hollow it out, make it look like a wheel with a rim, kind of. And then there's one other thing I want to do, and I'm honestly conflicted about whether it'll even work. Luckily, features can be undone, and these wheels print fast enough that I can, if you fail, you can always try again. The original design, the students put rubber bands on the wheels, which is an awesome idea. The rubber bands tend to fall off. They fall off frequently. They work awesome when they're on, but they fall off frequently. I mean, they're rubber bands, right? I think in order to try to help that, I am going to add ever so slight of a dish to the outer diameter of the wheel. I think that'll help keep them centered and keep them from popping off. I think. So let's get started. I said I want to take 20 thousandths off the overall. So let's go ahead and do that first. Sketch. Give me a circle. And I should be able to, is there, okay. I kind of, see, I love the co-radial feature in SolidWorks. So maybe that's a minor, again, everything I've got to say about this software so far might be a minor gripe. There's nothing major. But I love the co-radial because it makes the circles concentric and equal all at the same time, locks it down in one move. Because here I need to go concentric, and then I need to select them again and go equal. All right, now I got a circle. That's the diameter of the wheel. I can accept the sketch. I'm now going to cut. So extrude, remove, 0.02, 20 thou. Just ever so slightly. We're going to shave it off so that it clears that outer tab. Ever so slightly. Okay, and it turned gray just because apparently the appearance is just on the outer surfaces. So that's fine. I mean, honestly, when we print it, the slicer is going to handle the coloring anyway. I will probably, out of completeness and the fact that I will probably make these files available somewhere in the future, probably go back and change the appearance. Anyway, make it all match. So then we need to hollow this guy out. First of all, let's go back to the assembly and check and make sure we're clear that tab. Give it a second to refresh. Is there a force refresh? There is, except it must have already been done because it blacked it out on me. So it should clear that tab. I mean, maybe just barely, but it should clear that tab. It's still hitting this, so we're going to hollow it out. Like I said, it'll be kind of like a, an actual wheel on a rim that way. Plus it'll be lighter. So that's next. Whoops. We don't want to alt tab. Again, SolidWorks workflow. I'm going to sketch on this again. Sketch. This time I'm not going to make the circles equal. They're going to be concentric, but they're not going to be equal. So I need 2 circles because I'm going to cut out what's in between them basically. And here, whoops. I saw that coming. Select the circle, concentric, and circle, concentric. Okay. Now, will it let me do a dimension for like wall thickness like SolidWorks would? If you have concentric circles in SolidWorks, you can do like this. Yep, and get the distance between them. When you don't really care so much about what the diameter is, I care about what the wall thickness is. So I should be able to do the same thing here, right? And if I leave 1/4 inch, that's still pretty meaty. Can I get away with 1/8? I'm visualize. So I keep calipers around really just so I can visualize what does 1/8 of an inch actually look like, right? Because sometimes we forget, like no matter how many of these designs we do, like this part looks huge on the screen. I mean, 1/8 of an inch ain't a lot. But honestly, in this case, I think it'll be fine. I think it'll be fine. I'm going to leave it there. I am going to give a bit more wall to this because they are kind of snug. This flattened feature is kind of snug on the shaft. I don't want this to deform. I am going to give that more meat so that it sort of prevents that deformation. Again, I don't really care what the diameter is. I care about the wall. So 0. I mean, 125 doesn't look terrible there either, does it? That doesn't look terrible there. And what did I end up with for a total thickness of the wheel? Because that's going to determine how deep I can cut this thing. Actually, do I care? So normally, and here's where my mind is at. Normally, I would measure this. See that is now 380 thousandths of an inch wide. I'd subtract 1/8 of an inch if that's what I want the face width to be, and cut that deep. However, I'm wondering right now if I hit this sketch, if I can do an offset from, well, it's going to have to be from this face. I was gonna do it from that face. That would be bad. That would leave us with a lot of unsupported stuff here. But if I can do it from the red face, offset 1/8 of an inch, that would be kind of perfect. Extrude. We want to remove first. Blind up to face. I'm going to select the face. So right now, if I just hit go, see, it would remove the red. I don't want to remove the red. If I do an offset distance of 0.125, that's kind of exactly what I want. Now 1/8 of an inch may be way too thin. I will admit that. But I'm going to go with it for now. I'm going to go with it for now because that looks nice and svelte, nice and light, if you will. And I am, in this case, this part is done. Well, I'm going to cut out that groove I mentioned, but this part is effectively done. So I'm going to go ahead and fillet the inside now. I'm not going to leave it square. I would never leave it square. Why would you do that? That's silly. I got it set. What is the fillet set at right now? 0.4? That's kind of massive, and it's adding a lot of material. 0.25. That is just under, no, it's still added. Let's say it's just under that rim, but it's adding material because I'm so thin. 0.1875, another weird number, unless you're used to imperial units. 1875 now is below that rim. That's going to add a lot of strength, even though we're only at 1/8 of an inch. Well, we're at 1/8 of an inch, like at the thinnest part, which is only this little bit exposed. Let's do it. Why not? This little bit exposed is all that's 1/8 of an inch, right? It's thicker from there all the way out. Now that I've filleted it, which will add a lot of strength, a lot of stability, and we'll pop back into the assembly and make sure we actually cleared. We should. I mean, yeah, by like a mile. So we're clear of everything. The only thing that's going to be iffy is this. Like if the solid model and the physical parts aren't dead nuts, we may rub there. That's not too great a concern. I think most of the interference we were actually getting was from this little knobby here on the motor or on the gearbox. So I'm going to go with that, and then I'm going to pop back into the wheel to cut that. It's going to be a very, 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 very shallow groove, and I'm going to do it as a revolve cut, which I don't think I've ever done in Onshape. But what I would normally do is just grab that. I'm going to sketch on that front plane. Let's actually orient it to the front just for grins. And I'm just going to pick one of these edges. One side, it only needs one side because I'm going to revolve it all the way around. But I do need a line to denote where the wheel is. And I'm going to do it with I'm going to try it. Now, again, this is the thing about this kind of work. This may not work at all. Like what I'm doing here may not work at all. I may have to scrap the idea once I try it on a physical part. I won't know that until I try it on a physical part. So I'm going to, let's see, coincident. And I am noticing already just trying to select, will it let me? Can I do that? No. That's kind of annoying. Whoop, and then I deleted the whole sketch. Nice. I was trying to grab this edge, and in SolidWorks, it'll let you grab this. It's not really a line because it's a circle all the way around, right? This edge is not a line, but it would still let you grab it for purposes of sketching and doing what I'm about to do. Like, I can't tell you how many times I've done this exact thing. So, yeah, see, it's not letting me snap to anything when I create it, which I don't like. Am I going to just have to suck it up somehow? I mean, because I can go here and I can make that coincident. And all it does is move it up and down because I can still go in and out, right? That bothers me. That bothers me. But I know, I mean, clicking on that, I know the wheel's 2.5 inches in diameter, so I can always just set the dimension. I hate it. I would not do this if I had the ability, literally to do it any other way. I don't see another way. So I'm gonna set it to the diameter of the wheel. I don't like that because then if I change the diameter, I then have to remember to go in and change this dimension as well. Now, I'm not likely to change the diameter because this came in as an import, and I don't actually have a dimension on it that I can change. Like there's no sketch to change. So not an issue here, just as a general workflow thing. I'm not nuts about what I just did. But then my little arc will be the sort of meat and potatoes of this cut. And I want it to be like insanely shallow. And I think the best way to do that is going to be to define a point there that I can dimension to right in the middle of it. Because I don't care. Like, it's going to want me to define the radius. I don't care. And honestly, I don't even know. Like, I don't know what the radius is. No idea. What I care about is the depth of the center. And honestly, I think I have a whole thing of rubber bands here because I have no idea how thick a rubber band even is, and especially when it's stretched over a wheel. So real gentle touch on my caliper. I'm going to try to get an idea of what that is. Real gentle touch on my caliper. So it's about 50 thousandths unstretched. Stretched. Let's see, stretched. This is handy to have a home office with a bunch of junk in it. So stretched, and it didn't stretch much to get over this wheel. At least this rubber band didn't. Like, and as I'm looking at my little collection of rubber bands, I think this is the only one in here that I have this size. But now if I use the depth on the real gentle touch so as not to squeeze the rubber band. 3. That's really about... what, 37 thousandths? It lost that much thickness, huh? That much, 37 thousandths. So it lost what, 13? So if it's 37 thousandths stretched, call it 40, cut the groove depth in half. Now, that's also going to cause it to stretch less, but, I mean, again, this is a guess. This is 20 thousandths is a straight up guess that'll inset it about halfway, but it won't stretch so much. It might fall off even worse. The worst case scenario would be if it's not actually riding on rubber band, right? If these 2 points were proud of the rubber band and was only riding on these 2 points, that would be the worst case scenario, because that would be like the worst traction you can imagine. But let's revolve that guy. I thought as I was moving around I had an axis there. Do I not? Is that not an axis? Like, why is that gray line not an axis? I mean, do I need to create it? Yeah, that's the other thing too. SolidWorks would allow me to just select this because it knows that this is a round part, and right there's an axis in the middle of a round part. So I probably have to create an axis. How do I do that? Never done that in Onshape either. Let's see. We got to have some. So we got plane, offset, surface. It's got to be an axis somewhere, right? Helix. That's all sheet metal stuff. Weldment stuff. Helix, offset, surface, planes, move face, delete face, transform, switch, mirror. Those are all features. I want a plane. I want an axis. So what if I click that? Do I have an option to like change it? No, I don't. Offset surface? Nope. That's just surfacing tools. Modify fillet. I need an axis. Am I just being blind? Those are features. Those are surfacing tools. Definitely don't want to delete the part. Why do I have a plane? What about Helix? Is there something hidden here I missed? All right. Having done, I mean, I don't talk about this a lot, but having done some really advanced CAD work during my graduate work, if it's actually capable of doing the things in that list, that is pretty damn impressive for because yeah, just mathematically some of that stuff is really hard to get right. But that's neither here nor there. We really need I really need an axis. How the hell do I create an axis? I mean, there's nothing in any of these options. I've already been. This is like the workflow stuff for collaboration and whatnot. Why is plane the only option I have? Better yet, why don't you let me select any of the round things, like that are literally right here. Like, this is round. Let me select the round thing. It's mildly frustrating. While I sit here on a live stream and try to figure out where, I mean, they gotta have an axis tool, right? Like, it's gotta be there, and I'm just missing it. I mean, do what most engineers do and just see what Google has to say. Onshape reference axis. See what it has to say. I mean, the first hit is, why are there no axes in Onshape? Right now, you can use circular edges, sketch entities, and cylindrical faces to infer an axis. I mean, is it just because that was imported that it doesn't think that's a circle? I mean, it says they're working on it, like they've put in a user request, but I don't understand why we don't have it. So let's try. Let's try this. I doubt this is going to work. Let's sketch a line. And again, get the front view. Let's sketch a line right on that plane and make sure it's on the front plane. I'm going to set it to construction. There's no infinite length option, is there? No. All right. Accept that. Take that sketch, make sure it's selected, revolve, axis, boom. Haha. Take that. So I just basically created a construction line that's acting as my axis. Cool. And if I click remove, then I get my, preview. And that's, I mean, I was going to say that's what I want. That is a strong phrase because I don't know that's what I want. I don't even know if it's going to work. That's what I was trying to do. Let's put it that way. That little dish is what I was shooting for. Whether it'll work or not will have to remain to be seen until we've got one of these robots running around on the ground. God, I hate that overhang. I cannot express right now how much I hate having that motor stick out. I just hate it. Like the gap, I've come to terms with the gap. I can live with the gap. I got a plan for the gap. Gap is good, right? The gap is good. I cannot express how much I hate that overhang. I liked it nice and tucked in there, but I don't have a lot of choices right at the moment. Let's drop the other wheel in while I'm in here. Insert another wheel. And we want to go revolute with this edge and the screw hole edge in the shaft. So this motor shaft is threaded. Off the top of my head, I forget with what. I think it's an M2. So really, it just takes a single screw through that wheel to hold it on. And that's part of why it fits so snug. Is naturally the thing's gonna torque and going to be some backing out. Now the D shapes, the flats in that shaft really help with that. They don't necessarily take it all out. There's still vibration back and forth as you reverse and forward and whatnot. But it kind of is what it is. So from here, and I'm taking a look at my clock because I've started to get noticeably sleepy here. But knowing that I started late, I wanted to make this video and this stream last, sort of the use. I started late, by the way, because there was a college fair at the local high school. And as I are a college professor, I probably should be at such events. So I did that, and that lasted till about 7:30. It's about a half-hour drive to get back home. Plus, you factor in that you never leave those things quite on time, right? I wanted to make sure, so I pushed the stream back a half hour. That's why I was late. But I wanted to flesh it out and make sure we got good time in here. So what I'm thinking is to sort of solve part of my aesthetic hatred right now and actually go ahead right now and put in sort of a cover for the motors. And the reason I want to do that is because I want to right now sort of take care of, we need plastic to sort of extend up and under to support this PCB. And before I put that platform in, I want the motor cover, whatever it ends up looking like, to be in there. So I think we shall do that now. Cover up those motors. So I want to go back to the chassis. Do I want to do that? No, I don't actually think I want to do that back at the chassis. I want to do it here. And I want to do it here because I want to do it in context, I think, because I want to see. I don't want to reference, like, I don't like in context references if I can help it. I know I did it in some other cases. I don't like it if I can help it. I just want to be able to see where these parts are, because then I can eyeball and dimension. So I'm going to right click this guy and edit it in context. I might as well create a new one. I mean, I'm not going to do any referencing. I'm going to start on this top surface, right? That's the right surface. And I'm going to sketch, and I'm going to go ahead and get a little frilly with the design here of these motor sort of covers right out of the gate. A little more frilly than I have been, frankly, because I don't see a better way to do kind of what I want to do. I mean, I could fillet it. I might as well just sketch it in. And here I am talking about things I haven't actually shown yet. So what I want is I want an arc, probably nice and shallow. Like, I'm not even sure I want it tangent. I'm not sure I even want it tangent to that. I might want it tangent. I don't know. Nice and shallow. I want kind of an arc coming out, and then it can go straight back and in at a corner. And I can fillet this back corner. That's fine. But this is, I want it too shallow to be a fillet. And first, I should have checked. Am I on the right side? Let me get out of this sketch. I can redo it. I only had one curve in there. I want to be on the right side. I want to be able to mirror it just like I did before. But I want to be editing the same side when I do that, because I think I want to just add it to the mirror. So I need to be sketching on this left side in this view, not the right side where I started. So sketch, grab me a curve. And really, if I come out and sort of get in line with this motor, just under in line with this motor, I've got plenty of material for the screw bosses, or the screw inserts rather, that are going to end up supporting that PCB. So let's go ahead and do that. Grab that nice shallow curve. Grab that. I am going to make it tangent because, you know, I would. That's, you know, how I operate. So tangent those two guys. That's going to affect how shallow I can get it. But if I go shallow here, now what I'm pretty sure I don't want to do, I should say, I don't want to make it tangent with like a straight line coming out this way. I want it to be shallow. Tangent would make it like a fillet, and at that point, you know, I might as well have filleted it, and that's not what I want. So that's not what I'm going to do. We're going to go here. We're going to knock it there and here. That guy's locked down, right? Yes, good. This guy needs to be... Now, I notice they don't have a... I forget what SolidWorks calls it. Oh, we can't do horizontal, but we could do coincident. Oh, no, I can't because I don't have anything selected. Coincident should align them. Yes, good. I'm going to eyeball this guy and literally just eyeball it, because I mean, we had issues with the old chassis hitting the wheels. There was some binding there. I don't want that, but as long as I'm now... As long as I'm like plenty clear, I can just make up a dimension and be happy, right? So let's do that. I mean, I'm good with that. Let's call it 375 and get out of here. That was what I ended up taking off of the motor mount anyway, right? And we'll just put it back on. Do I want to bring that? Let's look at the top and see what we're actually covering. So we're covering the motor. I want that nice and shallow. Do I want to come all the way up is the question. Probably come all the way up, and the more I come, the steeper. I want to be back here by the motor. I don't know exactly where. I mean, if it sticks out a little bit, it's not gonna like give me heartburn the way that some of this stuff has. But so somewhere in that neighborhood, I'm going to define a radius, and I don't necessarily care what it is. I'm just going to make it so 3875. Let's 0.875. See what that looks like. Very close to what it was. And that's entirely made up. There's no reference for that at all. I just know I wanted a really, really, really shallow curve there. So we'll do that. That's my sketch. I'm going to take that. I'm going to extrude that. And I am going to extrude that, not blind. I'm going to go up to face. And this time I actually am no offset, just going to extrude all the way to that. Because we know we're already clear of the motor. we know we're already clear of the motor on that face. Call that a day, right? So from the top anyway, which is where you'll mostly see this thing, right? Because we're tall, it is not. That's what it'll look like. And I will knock off this corner with a nice healthy fillet in the back. I will also add a fillet here, so that's not just a sharp transition. It'll be a nice smooth like S-bend. And I think that'll look very okay. I'm going to take these two items, the sketch and the extrude, I'm going to move them into this folder. You should. Oh, I can't hit control. Don't hit control. That's SolidWorks. Drag them into the folder. That's doable because I didn't reference anything after the mirror, or I didn't reference the mirror either. Now, if I edit this mirror, I should be able to add that extrusion and get it as well. Right? So now we're good. We got material out here that I can now add onto in order to get the platform that this thing needs to sit on. I am very happy with the fact that that actually worked. I mean, let's face it. I mean, sometimes these modeling ideas don't always work. But that one did. Again, we still got the gaps there that are absolutely hideous, but I've got an idea to close those off. I'll do that sort of towards the end, I think. Now, before we call it a stream, we've got a few minutes. I'm going to go ahead and build that platform up and get that knocked out of the way. So, I went to great lengths to get an accurate height here. And after I did that, so this plus this, basically this black plastic from this female header and the black plastic from the male header adds up to our height. After I did that, and went through all of that hassle last week to try to get this thing mated correctly, I realized that this combination is no longer the plan. Like, this female header is a standard female pin header. And it came in from KiCad as the default standard female pin header. It occurred to me after the fact that it would be better as a machined pin header. So the pins in these, you look at them, they're square. They're actually stamped or sheared off of stock. You know, a roll of stock comes by and it's just chunk, 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 stamping it out. Machined pin headers are actually turned little pins. And they're usually what is recommended for things that have more need for mechanical grip, right? They're, rather than just a couple of spring-loaded things, they're actually like 4 points of contact that are spring-loaded. They're machined pins. They're tighter tolerance. They have guide tapers to center them. It's an overall better header. They're not much more expensive, but if you need mechanics out of pin headers, usually the recommendation is to go with machined. I did that. Problem is, I've actually ordered them. They're here. Well, not here. They're on my desk on campus, but they are significantly shorter than this. Significantly, and that's because of the way the pins fit together. This thing, I forget. I'm not even going to bother measuring it. It was like 1/4 of an inch tall. Yeah. So they're significantly shorter, and the problem is, so, and this is, I mean, it's a good example of why you can't always trust the AI large language models, because it told me that the square standard should also fit into the machine, and that is absolutely not true. I tried it; they just plain don't go together. So I can't mix and match. Honestly, though, I mean, normally lower would be better, but I basically have, I mean, the Arduino has got standard female sockets, which means for the Arduino, I have to use these standard pins, which means it's going to sit at that height even with that board anyway. And these really aren't doing a mechanical job the way they were, because I'm about to add screw bosses so we can screw the thing down. So even though I've got them, I can use the machine pins, for instance, here on the motor driver, because that doesn't have anything else, no screws, no nothing. So that would be good. These, again, these are a mistake. I grabbed pins when they should be female sockets. So these are going to be standard female sockets because the sensors have standard male pins that need to plug into them. So really, I mean, we're talking about these two that are going to be machined. This one could stay the same because it's going to be at the same height anyway, and we're screwing it down. So I'm just going to live with that and not worry about. I was working through my head of going out and finding a data sheet, figuring out what that height is, adjusting, even though the assembly here won't be correct. I'm not going to do any of that. I'm going to let the lazy take over and just measure here. Figure out how tall we need plastic. 439. Again, I don't really want to be tall. I don't really want to be short. I'd like to be dead nuts. Because that's going to put extra strain on that electrical connector. However, a couple of thousandths here and there, I mean, there's enough wiggle. Honestly, there's enough wiggle in just the fact that that's soft. The pins are soft. There's easily that much wiggle in there that a few thousandths isn't going to hurt us. So 439, dang, just for rounding purposes, even 440, just to make it a nice even number is probably okay. So I'm going to do that. I'm going to call it 440. Write that down before I forget it. 440 is what I'm going to do for height. Now, aesthetically, I think it will look best if it is this full width from here to here. This is one of those artistic modes, right? Not scientific. I think full width from, even though if you look, this does not quite line up with the back. But if I go from the back to the front of this board, or even a little beyond it, because I'm going to need room for the insert. But full width, I mean, basically out to like here. And then, of course, as with everything later, it will get filleted everywhere, make it nice and pretty. That's what I'm thinking. Just for now, a simple rectangle, couple of holes for screws, for screw inserts, and call it a day. So let's go ahead and edit that in context again. And again, create new, because I'm not going to actually do any in context references. I just want to be able to see my components. Grab that surface, sketch. Now I will not, well, I will not be moving this up to either motor because it's only on one side. It's not symmetric. I'm not going to be mirroring it. So there's that. We grab that corner. We grab this wall. So now we're even on three sides. And I am strictly guessing here, but we're going to go in that neighborhood somewhere and pick a dimension that kind of makes some sense. You know, isn't just a inch and a half. Looks good to me. I'll drop a hole in it and see what it looks like, but looks good to me. Grab that and extrude it. 440, 0. Whoops, gotta select the depth, buddy. 0.44. That should come up to meet the board-ish. It's actually probably, I think it was, what, a little tall? A little short. One away or the other. Close enough. So we'll accept that. I like that. Now, I'm going to put the holes in, and I am in this case going to do context references. There, because I don't want to go through the hassle of figuring out. I don't want to go through the hassle of figuring out where those holes exactly are. So I'm going to grab that. I'm going to grab that. I'm going to make it concentric. That's a lot of dimensions that, honestly, at 10:30 at night, I don't feel like grabbing all those dimensions. Just grab that, make it concentric. There. There's where my holes are. No dimensions needed. I'm going to accept the sketch before I forget to accept the sketch. I would normally hate doing in-context references like that. However, again, time speed, what it is. Like realistically, it's not going to hurt anybody. It's just plain not going to hurt anybody. I don't like doing them because if, say, this were a machine that I was building for a factory floor, which I've done a ton of, and I go and change where these holes are on this PCB, it's going to, like, the model is going to automatically move them in SolidWorks or in Onshape. It'll automatically move them. I may not know that, though, if I don't remember that I set them. So then I end up with pieces like I could cut, say I cut this piece, right, machine it out to the new revision, but I don't know that it changed, and I try to put the old PCB on it, suddenly things don't line up, right? Because I don't know that change cascaded. That's why I tend to stay away, and I would take the time normally to find the dimensions of exactly where this hole lands, say within reference to this corner. Again, in this case, we're 3D printing the thing. There's a lot of give in this connector, really side to side. In fact, I just bent one off screen here as I was playing with it, trying to explain, in context. So there's a lot of give in things, and right now that's good enough. So I'm just going to, for now, I'm going to close the context. We got the sketch. The sketch is really what we needed from the context. I am going to jump back to the assembly. I need a dimension. I don't know what bolt that is or what screw. So 091, let's convert. 091, 25.4. Like 3.8 thousandths. No, that's not right. You got to multiply, dude. You got to convert in the right direction. That's 2.3. 2.3114 millimeters. What is 2.5? 25.4. 098. That is definitely not 098. Let's jump to my favorite tap drill chart and see what it says for clearance. Little machine shop tap charts. These, I mean, I've literally been using these since undergrad, so like 20 plus years. I love these charts. Also, I have a copy of the Pocket Companion of Machinery's Handbook that I always keep on my desk, and the page flags you see, one of them are the tap drill charts. However, it's very hard to, on a live stream, share what I'm looking at in this book. So I've also, when I need it, this is my go-to online version, PDF version of a tap drill chart. I don't print them out anymore because I have the book. But, so we've got what? We've got 2.3 millimeter clearance. It looks an awful lot like a 2.2. I don't want a 2.2 screw, partly because I've already got M2 inserts back at campus. So even though 2.3 looks like a close fit M2.2, we're going to go M2. So I'm going to go over here to McMaster Car, and I'm going to back out because that's an M2.5. And we're going to back out to M2. Again, I go with the long one, because if the hole is long enough for the long one, then it would be long enough for the short ones. Deep enough, long enough, deep enough. Anyway. Let's see. Number 30, drill bit, 4.7 millimeters, 4.7, 25.4, 185, we'll call it 200. 200 thou deep, number 30 drill bit. So we need to go to the part. I don't need the in context anymore. Again, I needed the sketch. The sketch was all I needed. We'll make a hole, a number 30 drill bit this time, smaller. 30, make it flat again. And what did I say? 200 thou, 0.2, 0.2. Boom. All right, I got holes, 200 thousandths of an inch deep. Go back to my assembly, and because they were, give it a minute to refresh, because they were in context, the holes line up without any additional work. Love it. Love it. I think, well, actually, I was going to say I'm going to call it right there. One more thing I'm going to do is I'm actually going to download this because I need to start getting these in there before I forget what I've got. So I downloaded the model, right? A step file of the model. They also offer all the, other formats. But a step file, I'm going to import it anyway. It's just as good. I would not, now I should disclaim this, my normal workflow, I would not, and in fact, I recommend anybody that I teach SolidWorks to, I would not download from McMaster and import into SolidWorks. I would not. And I will show you why. This in the upper left or upper right corner is exactly the model. Like this drawing was created from their solid model. And this I want to also disclaim this is not a knock on McMaster. If anything, it's a knock on SolidWorks. So I'm going to import that part I just brought in. I don't need a composite part because it's just one part. We're going to import it to this document. Oh, that's good. We're going to import it. It takes it a minute. If you're antsy, you can look at the notifications and see where it's at. So it's translating it right now. And while it's thinking, like, how fast are you going to go? Do I need to? No, it'll be fine. So the reason I would not import this into SolidWorks is all of these extra surfaces are rendering horsepower that your PC needs to, all of the threads, right? These threads are true dimension. They've got surfaces all over, right? Counters, everything, countersinks or counterbores, countersinks. Let's call it a chamfer. Anyway, it's got all these extra surfaces that, for the purposes of our assembly, don't matter. I don't care about this knurl. I care that I've got a part in there called, what is even the part number? 94459A120. I care that that part is in my assembly so that I can get it in the BOM and have a bill of materials that's accurate. I don't care about all these extra surfaces. All these extra surfaces are chewing up computer horsepower, and that will choke SolidWorks even on a small assembly like this. If your computer's not up to snuff, even by a little, all of those extra surfaces are things it has to render that will absolutely choke it. In SolidWorks, if I need this, I would go right here to McMaster. I would look at this drawing. I would model a quick and dirty 3.6 millimeter diameter by 4 millimeter cylinder and run an whatever an M2 diameter major thread hole is through it. That's it, a cylinder with a hole. And then I would name it this part number so that it shows up in my bill of material. Fewer surfaces to render, faster model rendering. I am importing it here on purpose because, again, a portion of this series anyway is for me to try to kind of put Onshape through its paces. Also, as I figure it out, I want to see if it's going to choke. Like, it might. I don't know. But every one of these holes everywhere. So there's 4 there. There's 2 here. There's 3 on each motor. We got sensors we haven't mounted yet that are going to get inserts. All of them have all those extra surfaces that take horsepower to render. And frankly, they don't matter for the accuracy of our model, right? We know we got a plastic piece here that we're going to put the insert in. We know we sized the hole correctly. The diameter of those, or the exact geometry of all those faces does not matter one bit. It matters an awful lot to program performance, though. So again, I normally wouldn't do that. I am doing it here intentionally. I'm going to hide that whole assembly so that I can put them in, and let's go ahead and I'm going to stop. I'm going to put these in and stop. We can get the rest of them on later episodes, but I just wanted to, I've had that on my chest for a minute. I wanted to. So again, I'm also, like with the wheels, I really don't care what the orientation of these things is. So I'm not going to lock them down completely. I'm just going to do a revolute mate in the hole. And did that orient correctly? It did. So I'm happy. And I'm going to revolute mate in the hole, and I mean, they show up here with degrees of freedom because they do. I can rotate them, right? The Revolute Mate allows them to rotate. If I grab this, will it let me? Will it actually rotate? Yes. See, it rotates a little. That might be a little rendering slowdown just as I rotate it, but overall, like I'm talking in SolidWorks with enough of these inserts in a assembly, even rotating the thing will slow down. And here, I mean, it's pretty speedy, right? Again, there's only two, but I want to see what it does. So there. Now later, again, I am going to stop it here in just a second. I am going to say that later, I think, just for aesthetic purposes, we might do something cool, like cut out a centerpiece here so that it's just kind of two standoffs, maybe. Might leave it fully supported. I mean, full support isn't a bad thing. Full support isn't a bad thing, but I mean, realistically, the PCB, I mean, this thing, I gotta find one. This thing isn't even an inch long, I don't think. I mean, so 3/4 support, half support is probably just as good as full support. So, all right, I'm going to go ahead and switch it back to the full screen. We're going to call it there. Thanks for tuning in, and in the future, thanks for watching. This is past me saying hi to future you, which is weird how many timelines are going on here. Anyway, thanks for tuning in. I hope this was helpful. Hope talking through my thought process was helpful. That's the whole point here, is to sort of walk through and what I'm thinking about as I'm designing these things. I've got a lot of design experience, and hopefully it's helpful to somebody, right? So I look forward to seeing you again. We'll go back to the regular 8 o'clock time slot next week. At least as far as I'm aware on my calendar, I don't see anything that's sort of blocking that up. This was a late addition, that career fair tonight or college fair tonight. So again, thanks for watching.